Okay, in our fifth problem, we're going to be talking about how to get this equation for the least squares regression line, right? And it is possible to calculate this equation using some summary statistics. The information needed is in the formula packet, right? What does that mean for us, right? That in this formula packet, right on this first page, right, we have this little y hat equation, we have this r that we've discussed in these previous videos. Okay, and then we also have these two formulas, y bar equals a plus b x bar, right? And really that's just a play on this relationship, and it is based on the mean of y sample based on the mean of x sample. And then I have this b is given by r s sub y s sub x. Well, if I look at this equation, 2 equation, 3 equation, 4 equation, all right? Well, if I know r, and I know s sub y, and I know s sub x, I can find b. If I know y bar, x bar, and I found b, then I can find a. Well, if I know a and b, then I can find my y hat, my predicted equation, and this is my least squares regression line. So, let's look at that. What do we have here? All right? We said that we've got this y bar is equal to a plus b x bar, and we have that b is equal to r times s sub y over s sub x. Okay, well, if that's the case, what do we have? Let's do our substitution and figure out this value for b first. Substituting to find for b, we have this, r was 0.49, s sub y 12.7, s sub x 2.3, multiply that, that's 2.71. Well, now what am I going to do? I'm going to substitute into the y bar equation. If I substitute into this y bar equation, and it's important that these are y bar and x bar, very important, then that implies that 104.9 y bar equals a plus 2.71, that's b, times 12.3, that's x bar. So if I solve for a is 71.62. So what does that mean? That means that my least squares regression line equation, my LSRL, is given by y hat equals 71.62 plus 2.71x. Okay? Now, how would I interpret this 71.62? Well, depending on my data values, this might just be a y-intercept, right? If my explanatory variables collected or studied were nowhere close to 0, then the extrapolation to 0 for x is meaningless. Right? 71.62 could have no meaning, or it could represent my predicted y value when my explanatory variable is 0. Right? But this slope always means something. The slope means that for every unit change in my explanatory variable, my predicted value will change by 2.71 on average. And in this case, because it's a plus, it's going to be increasing by 2.71 units on average whenever x, my explanatory variable, changes by 1 unit. Okay, but this is the regression equation. Okay, now how would we describe the association between Mentos and Diet Coke expelled from a bottle, right? If this was the least squared regression, okay, well, what would we have there? What we'd have here is, I just realized this is incorrectly set up. I don't know what I was asking there, right? Here is just calculating the least squares regression line, okay, but what we do want to know, my apologies, right, my apologies there, is that what we do want to know is the following, okay, and that is this going to be a strong regression with an R of 0.49? And here's what we have. You can look to this website, it's hard to see, from DePaul University in Chicago. You can look towards this website, Duke University. But here's our general cutoffs. Our general cutoffs are going to be if R is greater than 0.8, we're going to say it's strong. Okay? And if R is less than 0.5, we're going to say it's weak. However, strong caveat there is this R value for strong, this R value for weak is really going to vary based on your area of study and the practicality of your area of study. Okay? Because here's what's happening for each of these. Okay? That if my R is 0.5, my R squared would be 0.25. And if my R was 0.8, my R squared would be 0.64. Okay? Well, what does the R squared have to do with this? Well, the R squared has to do with this in that this is saying that 25% of the variability in my response variable can be explained by the linear model with the explanatory variable, right? So really I can only explain some of it. While here, 64% of the variability can be explained. Okay, well, this is quite a bit better than this, but you'll find that in social sciences, simply being able to explain some of the variability by some other variable is going to be good enough. That there are some social sciences so that an R squared of 0.25 will be strong. Right? And there are some times that people will say, hey, my cutoff for strong with R squared is 0.5. Right? Well, what would that mean? If R squared was 0.5, R would be approximately 0.7. Right? And some people will say, hey, the cutoff for strong is 0.7, and the cutoff for weak is 0.3. Well, what's going to be your R squared at 0.3? The R squared at 0.3 is 0.09, and you'll say, hey, I can't even explain 10% of the variability using the relationship between the explanatory variable and the response variable. Right, but these two websites, I know they're hard to see on the video, but you should be able to link through them through the PDF. These two websites are fantastic to go look a little bit further on correlation and on the coefficient of determination, right? Correlation here, coefficient of determination there. Okay. Another little point that we might talk about at this piece is that the predicted value of y right, which is y hat, right? What happens with the predicted value of y? And that is that y hat, right, that the predicted value of y changes by r standard deviations in y for each increase of one standard deviation in x. Right? You can find this information in the book. And really it's because that this slope, which talks about my change in my predicted value, well, what's going to be happening here? Well, if each unit of standard deviation, right, that changes here in this s sub x is going to cause an r s sub y change in my slope. So y hat changes by r standard deviations in y for each increase of one standard deviation in x. Some people find it easier to look at it like that, because we say, hey, if this increases by 1, right, then what's going to be happening with this based on what's happening with the slope. Okay, so another long video. Apologies, this piece is very important. This idea is very important. This is just general information that's useful to know, but is better studied in more advanced settings.